Hit it.
Eeny, meeny, miny, mo, testing on the
Testing on the
radio.
radio.
Eeny, meeny, miny, mo.
Testing on the radio.
Eeny, meeny, miny, mo.
Testing on the radio. All right, Pete Giuliano, it is Monday, the 7th of February, 2022, and that makes us, what's the number, Pete?
Number 235,
Two,
235.
235, and it has been a long time since we recorded a SolderSmoke podcast. Man, I was feeling bad about it. It is entirely my fault. I blame it, and this is something that you say with great trepidation during the month of February. I was 6 weeks in the Dominican Republic, so I was away. Yeah, it wasn't really a happy trip. We were dealing with a family situation, but the good part was we were in good weather. So we're back now, and it's time to do another SolderSmoke podcast. While I was in the DR, I managed to make just one radio contact, Pete. I had my Ubidex with me for part of the time, and from a 12-story apartment, a 12-floor apartment in Santo Domingo, I made one contact with the micro Bidex on 17 meters CW. I feel virtuous.
There you go.
Virtuous, man.
You
CW.
mean there was something aside from FT8 on 17 meters?
I could hear. I use FT8 to find out if my receiver is working because I tune around to that frequency. I think on 17 meters it's 18.100 around there,
Yes.
and you can hear the all that kind of stuff. I actually did more shortwave listening this time than I did transmitting. I brought with me for the second part of the trip just a little Sony shortwave receiver that has a BFO in it, and I did some shortwave listening. I have my account of my heroic one solo contact on 17 meters up on the SolderSmoke blog. You guys can check it out if you like. But anyway, and there was one other bit of kind of electronic stuff that I did, Pete. Like many guys, I am the inheritor of the discarded electronic equipment of my family members, of my kids and of my wife. When they want to upgrade, when they want to get a new computer, a new laptop, a new tablet, the old one comes to me, right? And then they all make fun of it, like, "Oh, you're so out of it. You're so antiquated." Well, one of the things that I inherited was a Google Chromebook that my son was using for a while when he was in college before he upgraded to better equipment. So I got the Chromebook. It was manufactured in 2016, which is not,
Oh, not that
ancient.
old.
And I mean, yeah, but I mean, for the current generation, that's like ancient. But I got this thing going, and it's quite useful when I'm traveling because it's not worth anything. So even if it got lost or stolen or dropped or broken, it wouldn't be a great loss. But when you're down in Santo Domingo and this is the only piece of gear that you have that's working, it becomes pretty important. And then all of a sudden the screen just went out, nothing. I could see very faintly that a signal was making it to the screen, but it was almost as if the display wasn't strong enough for me to
Hiding in
actually
there.
see. It's hiding in there. So I did what you do today. I went to YouTube on my phone, which was working. So on the phone, I Googled YouTube, Chromebook, gave the number, can't see the screen or something like that. All of a sudden, three or four very helpful short YouTube videos pop up telling me exactly what the problem is. And they said it
Ooh.
with great confidence too. What it is that it's a screen. It's kind of one of these fold up displays. And inside there is a little connector that connects the motherboard to the display.
Comes loose.
Over time it comes loose and then or corrosion forms. The contacts are really very small. But they said if you take this thing out and apply some contact cleaner and reseat it, your display will come back. So I searched around. I found an old can of WD-40 in my in-laws' house, and I found a spray can of isopropyl alcohol. I had exactly one tool with me. I had one little tiny screwdriver that I used to tune the BFO on the shortwave receiver because I had broken the control.
Wow.
So it turned out that this one screwdriver
Everything
was the
aligned.
everything the radio gods have spoken. When I opened this thing up, the screwdriver was the perfect size for taking the screws out and taking the display out. So I pulled it out. I checked the connector. I applied some isopropyl alcohol and a little WD-40 just for good luck. Reseated it. Bob was my uncle.
Oh,
Talk
that's
about
great.
feeling virtuous, man. I felt like a radio genius having conducted this repair, and it improved morale quite a bit for me down there. So because I wasn't able to do a whole lot of radio during this trip. But anyway, that was my one good story out of Santo Domingo. And we were briefly back. We were back in the USA during the Christmas weekend, and I got back just in time to watch the launch of the James Webb Space Telescope. This is good news. This is good technological news, man. I was nervous about this thing. It's like 10 or 20 billion dollars. It's like a big project. It's going to be like 100 times more powerful than Hubble. They're going to put it out 1 million miles from Earth at this point called L2. And the thing is, they had to fold it up really light, like one of these origami, you know, things folding up paper sculpture folding. There were 300 points of failure. If any one of these unfolding operations didn't work, the whole thing would be for nothing. So, man, they had to be super careful. It would take them a month from the launch to get out to L2. And during the whole process, they were going to be gradually unfolding the heat shield, the solar panels, the telescope itself. And man, it went flawless. It's out there. It's out at L2. And I just think this was such a good news story. It reminded me a little bit of when they landed the rover on Mars during the midst of the pandemic. My son was he said, finally something works, and so that was really good. So anyway, it's out there at L2, and uh, an astronomer in Italy actually got a picture of it at L2, which is phenomenal. Can you imagine taking a picture of this thing? I guess it's about the size of a Winnebago, but it's 1 million miles away at L2, and this guy was able to catch it, not with an amateur telescope, with a professional telescope, but they were working out of Rome, and they got a picture of it. I put it up on the blog. So good stuff there, Pete. Good.
Well, you need to crank one more factor in.
What's that?
When was it actually designed and when was construction started? It wasn't last week.
That was a long
So
time coming.
so a long time ago, the existing technology I think is somewhere close to 10 years ago that they started on this. The technology 10 years ago is carried forward to today, and yet it worked. I mean, you'd have a better chance of using today's technology, what we know today, of making it work. So it's an even superhuman feat
There
for
was
all that to take place.
there was a kind of amazing kind of international brotherhood stuff going. NASA didn't launch this out of Cape Canaveral or Cape Kennedy.
No.
They launched it out of French Guiana.
Yeah.
The European Space Agency launched this thing, and that required them to send the Hubble Space the James Webb Space Telescope by ship through the Panama Canal to French Guiana, kind of a long and hazardous journey. But the rocket that the Europeans use has such an excellent kind of safety record. I think that's why they went with this particular rocket, which was, I think, a smart move and a very IBEW move.
Oh yeah.
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 Anyway, good stuff. Anyway, that was a little bit of good cheer on Christmas morning, I think it was. Pete, let's talk about benches. Let's move to the bench. I know we've got to talk about things that have been happening on a bench. Could I go first?
Sure.
All right.
Absolutely.
There's a few things I want to talk about, and I think it's better for me to go first, and then you could talk about what you've been working on. Uh, for me, one of the things I want to mention is that I had a bit of an understanding breakthrough. I've been for a long time bothered by my incomplete understanding of how the Gilbert cell mixer works, how the NE602 chip that we use so often. I've used it in many, many rigs. And every time I put it in there, I hear Gene Shepard's voice saying to me, but you don't really understand how this chip works, do you? And he was right. I finally sat down. This actually took place over a period of several months, trying to figure out how the thing works. And I thank a lot of people who are involved in helping me understand it, especially Alan Wolke, W2AEW, with some great videos. My phone is beeping at me. Let me turn it down here. Anyway, it finally occurred to me how I could understand how this thing works, and it required me to do something that I've had to do with other efforts at understanding, and that is to break the operation of the chip down into three or four different segments. One, how does it do the mixing? Second, how does it balance out the inputs, both the RF input and the LO input? How does it do all those three things at the same time? And how does it achieve good port isolation that we see out of the NE602? But using some of the diagrams that Alan provided and some that I drew up on my own, and I finally came to the point where I said, yeah, okay, I understand how the NE602 chip works. You know, the origins of this chip, the reason that Barry Gilbert really had to come up with this chip was that, you know, the way a Gilbert cell, the way a double balanced mixer works was known for a long time. But double balanced mixers usually involved fairly large inductors, fairly large transformers. They were looking for something that you could put on a chip, on an IC, where you didn't require all the physical space needed by inductors. So you needed a double balanced mixer that would do everything that our traditional SBL1s do, but all on a chip without the coils. You know, you crack open an SBL1 can, you could see the two little toroids in there. But they wanted to be able to do this to get the double balanced action and the mixing action on a chip so it could be used basically for the early cell phones. And that's what they achieved with a chip like the NE602 or the 612 or the SA602. It's all the same chip, really. And I couldn't get my head around it. I couldn't figure out how they were doing it. But then when I broke it down into the three different operations, I could see it. And so now I feel better, Pete, about using the NE602 chips in my rigs. I have put a blog post up with my understanding of this, with the different diagrams that I used. So if anybody else would want to see if my enlightenment works for them, take a look at the blog post. You'll see it up there. It's within the last couple of months. But you know, one thing I'll point out is that sometimes, what seems enlightening to me might not be enlightening for others. But for me, this works the way I understand it. And I've gone to some of the experts and said, you know, am I getting any of this wrong? And the feedback I got was, no, you got it. That's right. That's how it works. So I feel confident about that. That was a good moment. Now, I've one of the rigs that I used the NE602 in was my first single sideband transmitter that I built more than 20 years ago. Yeah, more than about 20 years ago or so, out in the Azores Islands of Portugal. It's based on a design in Sprat magazine, 3 Cheers for Sprat, by Frank G3YCC, who's now a silent key. But Frank presented in Sprat this very simple SSB transmitter. And I liked the design. I had most of the parts. I adapted it, and I adapted it for 17 meters and built a 17-meter transmitter, not a transceiver. I used the crystal filter out of a Swan 240 transmitter. So these crystals were built around 1962. Double lattice design, and I kept the carrier oscillator crystals for it too. I picked up the Swan 240 in the Dominican Republic in the mid 90s, early to mid 90s, and kept the parts for the filter because it was most of the rest of the rig was in bad shape. Anyway, I've been thinking about building a 17-meter, 12-meter dual bander. We've been talking about this. And so this caused me to kind of look at rigs that I had laying around to see if there was any bits of circuitry that I could use. I was briefly thinking about cannibalizing this old SSB Azores transmitter. But when I looked at it, I started thinking differently. I started thinking, man, I should get this thing back on the air. I should blow the dust off this thing, maybe improve the impedance matching at the input and the output of the crystal filter, apply some of the skills and some of the new test gear that we have, and see if I can get the transmitter back on the air. So I did, got the transmitter going. Then I started thinking, I need a receiver to go along with this. Out in the Azores, I had used my Drake 2B along with this just transmitter, and it worked fine. But now I said, no, I should have kind of a dedicated kind of solid state receiver to go along with it. So I had kind of up on my shelf a bare bones super hat designed by Doug Demore. This one was built from, I think, a Far Circuits kit by Dale Parfit, W4OP. I have played with this thing many times over the years. It's been on 20, then back on 17, then for a while on 40. But I pulled it out and I said, I'm going to put this thing on 17 meters. So this required some doing. I used my newly acquired understanding of the NE602 to build a down converter that would take the 17 meter signal, say at 18150, and bring it down into the range that I had the barebone superhead set up for. I had the barebone superhead set up for 40 meters. I didn't want to do a whole lot of re-engineering with it. So I just built a down converter using an NE602 to take an 18 megahertz signal, take it down. I ended up with having it come down at around 6.8 megahertz. So then it went into the barebone superhead at 6.8 megahertz, and Bob's your uncle. Then it converts the whole thing eventually to audio. I get the right sideband inversion that I needed, and it worked fine. I used a little one of these little crystal oscillator modules that are all floating around. They have different frequencies on them. They're not just crystals, but they're crystals with the associated, I think it's either FET or BJT transistors in there. And I found one for 25 megahertz, which was just what I needed. So I just popped it in there with the NE602, and boom, 6.8 was coming out. It was perfect, just right. I thought. And I did a video on this and I put it up. There's a fella who has come up with some really insightful feedback on some of these projects. I'm talking about Alex, R2AUK. Alex is in Moscow. And he took a look at what I did and he said, hey, great, good work. But the output of that module is probably too much for an NE602. He says you probably need to run it through an attenuator to bring it down to the right level, and you'll get better performance if you do that. This was a really good insight. And I checked, and sure enough, the module was pumping out way too much, 25 megahertz energy for the NE602. So I did a real quick calculation, built an attenuator, and got it so that the right level was coming from the module into the NE602. So now I have a receiver set up for 17 meters, and I have a transmitter set up for 17 meters. And the only thing I really need to do is figure out a way to net the two. Now, you know what I'm talking about with netting, but most of the people listening right now will have never operated anything other than a transceiver. But when you're using a separate receiver and a transmitter, which was the way we all did it back in the day, you need some way when you hear somebody calling CQ, there's a station I want to talk to. He's calling CQ. You need a way to put your transmitter on the proper frequency. So you have really, and I have over here behind me, here's the rig. I have a little switch. I throw the switch and it goes to spot. This turns on all the oscillators and all the mixers inside the rig, inside the transmitter. I can then tune the transmitter for 0 beat. And once I hear 0 beat on my receiver, I know that I'm on the same frequency as the other station. My problem was that when I put the spot switch on, I heard not one tone, but two.
Ooh.
So which one is the right one?
Yes.
Very confusing. So I started sort of trying to troubleshoot this thing, try to figure out what the problem was. I noticed that the problem really began at around 18116 megahertz. It didn't exist elsewhere in the phone band, but when I got close to 18116, I started to hear the other tone. So I just sat down with pen and paper, with an Excel spreadsheet, and with a program from Wes Hayward called Spur Tune 08. And I started saying, what is causing this second tone? What frequency combination is coming out of my VXO? I have a VXO running at 23 megahertz, and I have the carrier oscillator running at 5.176 megahertz. Now, there's a lot of calculations because it could be any combination of the harmonics of both frequencies. The good thing that SpurTune does is that it displays all of the harmonics up to about, I think about the 12th or 13th harmonic of both frequencies, and tells you if any combination of these will be producing a spur in the passband that you're interested in. So I'm interested in the 17-meter band. I'm interested in a spur that's popping up around 18116 because that's what's giving me trouble. So as I tuned around, I suddenly realized there it is. First, I got it wrong. There was another combination that would produce the signal, but that's not what was causing me the trouble. What was causing the trouble was the output, the main output from the VXO at 23 megahertz was interacting with the eighth harmonic of the 5.176 megahertz carrier oscillator.
Jeez.
And I knew that was it. There was a couple different ways to test it. And I was certain that was it. And sure enough, on SpurTune, it showed it right there. What was key was which way is the harmonic moving when you tune it. So when I tuned on the transmitter, I could hear the harmonic going down as I was tuning up. That indicates which combination you're dealing with. And sure enough, when I looked at SpurTune, that's exactly what was happening. When I was turning it up, when I plugged in the eighth harmonic and the main frequency of the VXO, it would be moving down as I tuned up. Bingo, that was it. So at this point, I departed to the Dominican Republic and I left the whole thing on my workbench. While I was there, I thought about all kinds of different ways to solve this. One of the ways was to just put frequency counters from Sanjian on both the transmitter and the receiver, and then forget about audio zero beating, just visual zero beating. Just look at tune it till two numbers are the same, and then I'm good. I actually ordered the frequency counters from China. They're here. I got them now. But when I got back, there's a benefit in taking time away from a project, in letting your mind kind of get away from it. And going to the Dominican Republic is a good way to do that. So I went away. When I got back, I started looking at it and I started thinking, man, let's not do complicated solutions. A complicated solution would be putting these Sanjian frequency counters in there. I mean, we even had a friend from Australia suggest the use of the Magic Eye. VK2 EMU said, hey, why don't you use a Magic Eye tube? And I said, well, yeah, it's a great idea, but it adds complexity. This is not a tube rig. So I said, why can't I just do what I can to sort of knock down the eighth harmonic from the carrier oscillator? If I knock that down to a point where I can't hear it anymore, even though it's there, it's not going to cause me any trouble. So I did a few things. I put the whole carrier oscillator in a little metal box. I'm usually not into a whole lot of shielding, but I did shielding around the carrier oscillator. I beefed up the low pass filter coming out of the carrier oscillator and moved the cutoff frequency up to around 7 megahertz, where I was trying to get a 5.7176. I put the cutoff frequency about 7. This would produce more attenuation down at the eighth harmonic. And then I built a little trap. I built a series LC circuit that would tune to 41 megahertz, which was the eighth harmonic. And I just experimentally placed it inside the carrier oscillator circuit. I'm using the carrier oscillator circuit out of the BitX20. And I found that if I placed this little series LC circuit tuned to 41 megahertz right at the output, right between the oscillator and the buffer, and then I watched it on my tiny SA, I could see that 41 megahertz signal coming out would just drop. It would drop by about 20 or 30 dB, a big significant drop. And I was hoping that this would be enough so I wouldn't hear it. So I put the whole thing together. Bob was my uncle. Now I can tune even down around 18116, and the only thing I hear is the actual frequency of the transmitter. I don't hear this spur. So, I mean, this was all for me really, really good, and it was a reminder of the spur problem that we faced when using the superhet, even the single conversion architecture. And I wouldn't have had any of this trouble if I'd been using a transceiver, really. But it's something to think about. And it's a reminder of how much attention we have to pay to spurs. Now, where do you find SpurTune? I know some guys are going to be thinking SpurTune. Now, I got SpurTune way back when as part of a LADPAC software package, I think that came with my original version of the Experimental Methods in RF Design, the EMRFD book. But WB9KZY found SpurTune 08 on the Wayback site for W7ZOI.net. It's under the EMRFD errata for the 3rd edition. So if you guys are really intent on finding this software, that's where it is. Anyway, make a long story short, now I got this rig set up here, Pete, and I've been making all kinds of contacts on
Ooh,
17
nice.
meters.
Nice.
I have it here on the corner of the bench. I just reach over and I make several contacts each day. Cycle 25 still not really kicking in, not yet. 17 is still mostly dead, but I've been working a lot of Caribbean stations, the occasional European, a lot of stateside stations, and having a lot of fun with it. Anyway, I've talked too much. Pete, what's on your bench?
Well, first off, let me tell you, I managed to find a crystal for one of my Collins KWM2s that'll put it on 17 meters, and I got it tuned up there. So all I need to do is just switch the antenna, and so I've been listening on 17 meters as well, and you hear a ton of signals at 18.1, but not too much CW or phone. I just don't understand. I mean, the band is open. You've seen it. The band is
Yeah.
open.
But I get a reality check. I discovered something, and I mentioned this on the blog. If you go up a little bit further to 18110, that's the frequency for the IARU Northern California DX Foundation beacon system. And they've got coordinated beacons all around the world that are constantly transmitting. And they got a website where you could see at any instant what is being transmitted. And I can't hear most of the beacons. The only one I hear regularly is YV5B in Caracas. All right. I can occasionally hear Victor Echo 8 Alpha Tango up in Canada, further north, and occasionally, the one in Peru. But I'm not hearing the Europeans and I'm not hearing the West Coast. Now, this may be partly due to my antenna, but I don't, I don't hear a whole lot of stations. So I'm thinking that 17 might still be not great, not as good as we wanted it to be. But anyway, I might have to improve my antenna. But listen, around 18110, that's the frequency for these beacons.
No, okay.
It's really cool.
I'll check
Yeah.
that out.
Yeah.
Okay, so we're talking about my bench. I'd like to tag on to your 8th harmonic. Okay, and I want to start with a little bit about crystal filters. Okay,
Yeah.
and there's G4CFY. Anthony owns a company called Spectrum Comms in the UK, and he has 2 versions of crystal filters he's built, and they're really superb. He does a superb job. As a matter of fact, the 9 megahertz version is what the Vienna Wireless Society used in their simple sideband transceiver project. I think you got one of those.
I do. I have one. Dean sent me one. I've got it.
So it's really nice build, small, compact, and really excellent. He makes another version, a 10.7 megahertz center frequency. So you have the 9 and the 10.7. And of course, the 10.7 would be excellent for 17 meters because you get away from the 9 megahertz problem with 17 meters.
That's good news.
Okay, so immediately you look at the 10.7 and you say, aha, I have a 3.5 megahertz analog VFO kicking around the junk box. So if I take 10.7 and 3.5, guess what? 14.2 puts me right on 20 meters. How wonderful that is. I got this nice, stable analog VFO, and I'm all set to go on 20 meters. Now, if you look at the tuning range of the VFO, you'd have to be around 3.3 to 3.6 when mixed with the 10.7 gives you the coverage. But at 14.2, the 4th harmonic of your analog VFO is right in the bandpass.
Oh man, I know.
The
bummer.
Yeah. So the thing is, you really have to watch these mixing frequencies. I mean, you saw the 8th. Just think about the 4th. The 4th is going to go right through the bandpass filter.
I know.
I mean, this frequency analysis is really, really critical on what you do and really important. Now, if you took that 10.7, instead of using the 3.5 megahertz analog VFO, moved it up to like 24, then you could do the sideband inversion routine and you essentially get the 10.7 difference. The problem is it'll avoid the low pass and band pass filter, but the frequency range is right in the 12-meter band. so so you can't just treat this stuff lightly. I mean, you really have to do a frequency analysis.
You do, and it's hard, and it's especially hard with the work bands because there was a lot of frequency analysis of this type done back in the day, back when more home brewing was being done on the 5 standard HF bands on 80 through
Yes.
10. And I think I sent to Dean an old GE notes that basically did this exact analysis that we're talking about, but only for 80 through 10.
The 5 bands.
Right. I haven't really seen anything like that that includes the work bands, which we're spending a lot of time on now. This is where the Spur Tune 08 program really becomes useful. But I agree with you. I have been kind of haphazard in my selection of IFs. When I was building my first or second BitX, I got the brilliant idea that I was gonna make a dual bander for 20 and 40. And I think I selected the IF frequency at 11 megahertz. And I could get 20 meters to work, but I could not get 40 meters to work because there was just no way. I kept getting all kinds of stuff, harmonics in the passband, because I had not been careful or rigorous in the selection of the IF. So yeah, you're right. You gotta be careful about that.
Right. And to that end, I had a blog posting through the whole month of January, and this general subject area is how to build a single sideband transceiver. And I have taken that blog posting and converted it to a Word document. And if you go to n6qw.com, you can download that document, and it covers things such as the crystal filter.
Yeah.
and what are you doing? It also, I took an attempt at documenting sideband inversion to show you how sideband inversion works.
Yep.
Another one is matching transformers, how to do the match. Really
super important.
People who are experienced homebrewers get that screwed up, and then they wonder why things don't work.
Yeah.
I also took some time to take a look at I'm getting 20 milliwatts out of my driver stage. How come I'm not getting 5 watts out of an IRF 510? So you really need to do the analysis. I mean, how many dB gain do you get in an IRF 510? And if you got 20 milliwatts coming in, you ain't going to get 5 watts coming out, So right. I try to spend a little time on the math. And hopefully this will be of some use to homebrewers, because I try to take every one of the circuits that you have in a transceiver by module. So this way you give you some kind of start. And then I got a comment that relative to, well, why didn't you go into the depth of the circuits and do all the analysis? Well, I'm trying to give you a feel of just some of the things you need to consider. On my bench is the PSSST, and it actually showed up on Hackaday.
Really cool. Very, very cool.
Except when it gets put on Hackaday, you get these guys, negative criticism. You did not put the code on a GitHub. So now I have to email you to get the code. Why didn't you put it on a GitHub? Well, there's a good reason for that, because then I like to know who's building this stuff and if there's any interest. On a GitHub, I wouldn't know how many people downloaded.
Right. Yeah.
By me putting the code. And then there were some other things is, well, you built that thing in modules. There's no circuit board for it.
Yeah, I know. Yeah, this is. I always think this is when you see something on Hackaday, it's kind of a mixed blessing, because you do get a wide audience and you do share it with a lot of people that wouldn't otherwise see it. But you're getting out of the ham radio community and you're moving into the kind of the much harsher software computer community, which is, I think, really, it lacks the kind of friendly collegial team spirit that we hope to see in ham radio. There's this attitude there that you should haze the noobs, which I can't stand that phrase. I mean, we talk about helping novices. They talk about hazing the noobs. And I think there's just a fundamental kind of cultural difference between the two communities, even though the technology is often in common.
Well, the one that really got to me was it's the PSST is a 7 transistor transceiver, 7 transistor. Some guy comes back and says, you lie. It's not 7. You got more transistors in the LM380N-8, so it's not 7. And you have transistors in the Arduino, maybe hundreds. So it's not a 7 transistor transceiver. Okay. there we go. I mean, it's just, there are 7 basic devices in the circuit modules, which I think, make the sum and substance of it. Now, there's another issue, Bill, that I think is important that comes out of projects like this. And I want to take maybe 2 seconds to rant a little bit. People will take the project. First, I always maintain that I see my projects as an experimenter's platform. I build them in modules. So you don't like this module, put a different module in. And by building a module, that facilitates the changes. But then people will say, well, I didn't use a 9 megahertz filter. I used a 12 megahertz filter, and I didn't use your code. I wrote my own code. It doesn't work. What's wrong?
Well, you built another rig, my friend.
Yeah, well, did you do the frequency analysis? For instance, with a 12 megahertz filter, you say, well, I'm going to put that in 12 meters, so I'm going to have a 12 megahertz VFO. Do you think you might have a problem, like on 17 meters with a 9 megahertz filter, the 9 megahertz VFO? I said, I'm seeing spurs. Or, what's wrong with my code? I don't know what's wrong with your code. And I try to suggest that when I document these projects, start off by building it like it was designed, because then you have a benchmark of performance. And then if you want to swap out the modules, just do it on a measured basis. Don't do it wholesale that you change all the modules and says, well, it doesn't work. If you change one module, you can always go back.
Yeah.
Where the basis.
Yeah, especially if this is the first real thing that you've ever built. I mean, that's sadly that's the case often, that the guys will try to do the first time and then they'll say, well, it doesn't work, and who's responsible for this?
So there's an offshoot of the PSSST called the P shooter. And the P shooter is a smaller version, a shrunk down version of the PSSST. And instead of using 2N22, 22As, I put some mimic amplifiers in there. So first email that I got about the P shooter, guy says, why did you use an OLED display? They're noisy. You shouldn't have done that. Well, okay, do what you want, but you heard, there's a documented video, you heard how it sounds. Tell me what is bad about what you're hearing. So I'm more than happy to share, but don't come back to me and tell me I did something wrong when obviously the results show that it doesn't. Now, you want to put a color TFT in there? Hey, have at it. Have fun with it.
Yeah, your mileage may vary. I mean,
something I use. Well, I get it working. If I say it's noisy, guess what? Modular approach, I can change that. I can try something else. But
there's also ways of dealing with the noise. I mean, I had noise with an OLED display. Then I put an active filtering in there and knocked it right down. So it can be done. Yeah.
So what is it? But anyway, I've been having a lot of fun working with these projects and trying to document it, and just more than happy to share with it. But what is so amazing is there's still a lot of brand new technology coming out. I'm seeing more SDR radios come out of China. Yep. Just take a tour through Amazon or eBay, and they're now down in, the most of them are QRP radios, 10, 15 watts, and most of them are in the $400 to $500 range. So I mean, I can see with time that's going to come down. So that's what I've been doing on my bench, and I'm still working on the P shooter, and I'm in no hurry to get it done right away. I want to do some things, but the whole idea is to get it something that's 6x4x3. That's the goal. That's the box size.
6x4x3.
Yeah.
Very cool. There's a few other things that are coming out of your bench that you haven't mentioned. One, Dean has had a big success with the direct conversion receiver.
Oh, yeah.
and he's produced some videos that he's just enthralled with this thing. There's just the
Yeah.
sound and how nice it sounds. It's we're those of us who fooled around with DC receivers know what he's talking about. You really feel like you're listening right to the ether. There's not a whole lot of frequency conversion and mixing and
Yeah.
filtering going on there.
We've had 99 requests. We're just shy of 100. 99 requests for the code. But something I want to highlight that Dean has done, I used the MC1496. He started off with an ADE1 just to prove the concept,
Yeah.
and then he homebrewed.
Yep.
So his is not using an active device. He's actually using a passive device with the Homebrew double balance mixer, and it sounds really, really good. And they're taking that on as a club project. It wasn't just an exercise in his part, but that's the next build for the BWS.
Yeah, I think he's trying to do one for 17 meter band,
Yes.
and he asked me about it, and I said, well, for a direct conversion receiver, you really need to build the VFO at 18.115 or like that
Yeah.
up there, and that's kind of hard to do with an LC analog
Yeah. Yeah.
VFO.
Yeah.
I mean, no problem at all for your beloved SI 5351, but
Well, I don't know if you heard the latest story. So he said he had it working on 40 meters first, and he had way too much gain in the RF amplifier stage. But then when he used that same stage on 17 meters, it was a little anemic. He thought that using a standard, what you hear on 40 versus what you're hearing on 17. So I suggested he build the J310 configured as a dual gate MOSFET, because one of the features of that has a pot. You can control the gain.
yeah,
So I said, if you're on 40, you can crank the gain down because you don't need it. When you're on 17, crank it wide open. So he says, oh, okay. And that was the same circuit that originally appeared with a simple SSB transceiver. So he built it. And he said, it's an attenuator. He said, it doesn't work. I said, well, Dean, all I can tell you is I got half a dozen of these at work, and it works good. And I said, did you do the LT Spice simulation? He said, yeah, I did. And he said, you're right. I can change the gain, and it changes. And he says, LT Spice says that's what it should be, but in hardware it doesn't. So then he started checking components. In one place, there's a bias resistor of 2.2K. He lifts it from ground, puts his ohm meter across it, and it's 22 ohms. So he thought he put the wrong value resistor, and then he looked. No, it's banded for 2.2K. He had a 10-pack. Every one of the 10-pack reads 22 ohms.
you got to check them.
So,
I check them. I check every resistor before I put it in there.
I could see he's not Italian, but I could see him raising it.
Well, one of the reasons I check them is because the color codes now, they're hard to read. They fade.
Yeah.
The colors are different. What used to be blue is violet. How could you tell the difference between blue?
Yeah.
All this kind of stuff. So I have a habit now. I just have the VTVM next to me, and before I put the resistor in the circuit, I'll put the VTVM across it and see, or the VOM, see what it is, what it tests at before I put it in the circuit. Yeah.
But
it could happen.
Short.
That'll mess up your amplifier for sure.
But I mean, you can just see his mind. He's done all these things. He looks at the spice. He looks at the wiring. There's no shorts that he can see. And then he says, okay, let's measure the components. And it was 22 ohms, not 2.2K.
But that's a satisfying troubleshoot when you look in there and you realize that. When you say, okay, that's it. That's what's causing the trouble. That's much better than just a cold solder joint or something else. That's a good troubleshoot. So he should feel good about that. He found it, which is good. And he used LT Spice. And like you always say, if LT Spice says it should work, and then you build it in the real world and it doesn't, you got to check. Something's wrong there.
Well, in that what I mentioned about the document that I published, one of the interesting things is about bandpass filters. And when you build a bandpass filter, you'll find that one component is really very critical, and that's the coupling capacitor between the sections.
Yeah.
And one of the problems, and I mentioned this in connection with the Nano VNA, is a guy built this, and he put his Nano VNA, and he got this really strange looking bandpass. And so he says, "What's wrong with your design?" Starts off, "What's wrong with your design?" So I said, "Okay." I said, let's take a look at this." And so I did the simulation, and you have a case of undercoupling and overcoupling. And the undercoupling kind of gives you a really pointed response. And overcoupling, you get like the saddle. It looks like a camel's hump, two camels hump. So you got to pick one that's going to give you the flat bandpass. So I said, "Look, here's the value of LT Spice." I said, "You can sit there without building any hardware and just change those values and see what the shape is." And I said, "It'll tell you right away, where you're getting close to the right value, because you don't want it peaked and you don't want a double hump. You want it flat across the top." So I said, "You tried changing C2." So he did that, and then he discovered he put the wrong value of C2 in there. But he was relying solely on just what he was measuring with the nano VNA without understanding Gene Shepard, understanding the impact of that coupling capacitor. If he would have done a little work with the LT Spice, he would have seen what would happen and how to flatten the response. So I'm adamant. Do it in LT Spice first and get the feel, and then use your nano VNA to verify what you built is actually right. I mean, you may get a different answer because you got a bad component or what have you.
In LT Spice, it's so easy just to change the value of any of those components and then take a look at what happens at the result. It's just easy. That's the whole purpose of LT Spice. So I agree with you. Pete, you also been working on homebrew crystal filters a little bit too,
Yeah.
right? Tell us about that.
Well, it's kind of interesting. I think that there's a real opportunity with a lot of crystals that are available to homebrew some crystal filters, and I've got about a half a dozen here. And I should tell you, I had a presentation to a radio club in the UK, and it was kind of interesting as I was presenting. This one guy got on and says, "How come you don't like homebrew crystal filters?" He starts off with that. I said, "Oh, well," I said, "Well, it takes a lot of fooling around to get a good filter." I said, "When I'm building something, I don't want to invest 5 or 6 hours going through all the characterizations and what have you." And I said, "So I have quite a few package filters. I'll get it working." I said, "But there's certainly room for including a homebrew crystal filter in there." I said, "But if you're going to do it, you got to do it right, and that may take more than 15 minutes." So he said, "Well," he says, "I wrote the software for the dishel." I said, "Oh, okay." So then, luckily, right sitting there, I had a 6-pole filter built with a dishel, and I put it right to the screen. I said, "Just to show you, I have built dishels." And he said, "Oh, you did a nice job." I said, "Well, thank you." So, I mean, the thing is, there's some people that are hard over, and there's a place for that. But if you can build, you found out you built a 10-pole filter that's amazing. So yeah, but you didn't do that in 5 minutes, did you?
No, it took a while. It took a lot of cut and try, a lot of experimentation, a kind of a mixture of using software like Dishel and other programs like and characterizing the parameters and then seeing what the result is. And you can't just say, "Oh, well, the software says that this should be the bandpass, so if I'm going to build it this way and that's it." Well, sometimes for a variety of reasons, it might be a little off. And I built this thing, and the first time I looked at it, I think it was way too narrow. So I realized by changing the value of the capacitors to ground,
Yeah.
I could broaden it, and I ordered a whole new set of capacitors and put them there. I think I did that once or twice till I got it to where I wanted it. The software was extremely helpful
Yeah.
in getting me close, but then there's no substitute for actually building it and testing it and seeing what the results are.
Well, my blog posting for today covers a homebrew crystal filter,
There you
9 megahertz, 9 megahertz.
Yeah.
And I went through the dishel process and the AAD, and I looked at it on a nano VNA, and it was crap. So I ripped out those capacitors I said to put in there. I installed 5 47 picofarad capacitors, adjusted the matching transformers, and look at the plot. It's flat as a pancake. So I'm saying, okay, there you go.
Yeah, I think that you're right. especially for beginners, there's and for guys who don't want to have to spend a whole lot of time reinventing the wheel all the time, there's a place for kind of store-bought crystal filters. And I've got a whole box of them over here
Yeah.
waiting for projects. But there's also an advantage in home brewing your own crystal filter a few times because you start to understand what they're talking about in terms of motional parameters, how those crystals really are the equivalent of LC circuits and how you put them in there. And it's just sort of a kind of a rewarding, I think, home brew process. It can be quite frustrating if you're not stopping to think about what you're doing.
Yeah.
If you're just sort of throwing a whole bunch of parts on a board and then looking at it and saying, it doesn't work. That Pete Giuliano.
Yeah. Well, take a look at the blog and you'll see. I looked at that and I said, perfect.
Really good.
Yeah.
Hey, you got anything else on your bench you wanted to mention?
No.
All right. We were talking about a second ago about IF selection, and I just wanted to update people on where I am with the 17 meter, the 12 meter dual bander project. So one of the things I want to do here is I want to try to use one of my beloved analog VFOs, and I'm trying to pick a good IF frequency. So I have to look at where crystals are available because we're not talking about bespoke, you can order from Jan or International Crystals, no more of that. You have to look at what's available. So I found that there are crystals available at 21.4772 megahertz, which is nice because it's like halfway between 20 meters and 12 meters, about halfway. So if I have that combination, if I select a crystal filter, an IF at 21.4772 megahertz, for 17 meters, I need to run the VFO between 3.3672 and 3.3092 megahertz.
Perfect.
And then for the 12 meter band, I need to run the VFO from 3.4528 megahertz up to 3.5128. So if I have a VFO that's running essentially from around 3.3 to a little over 3.5, I can cover both bands. It would be good. It would be kind of a neat way to do it. Now I ran these numbers through Spur, and I saw a couple of Spurs popping up, but none of them in like kind of the pass band that I'm interested in. There's a couple different frequency combinations that'll produce Spurs, but they're the kind of Spurs that should be easy to knock down. And so I'm not really that worried about it. So this is what I'm planning on doing, and that's I think what'll be the project for the rest of the winter. So if anybody has any ideas about that or sees any problems that I'm not seeing, please let me know.
You may have stumbled across something that would really be useful. Check and look in Mauser and DigiKey. They have 15 kilohertz wide FM crystal filters. 15 kilohertz wide FM crystal filters, and one of the frequencies I think is 21.5.
Wow.
And you could make that a roofing filter.
Yep.
Ahead of your homebrew filter, so that you're only going to pass 15 kilohertz worth of signals that'll be passed on to that. So you'll essentially have a roofing filter in the circuit, so you'll never have to worry about it. But check it, and they're really expensive, like $4 or $5.
I think we could handle it.
Yeah, check and see. I think one of the frequencies is 21.5, which you then could add a roofing filter in there, so that you're only passing 15 kilohertz worth of signals through that filter.
We'll check it out. Thanks a lot for that, Pete. I'll check it out. Hey, one thing I wanted to mention, bad dead soldering stations. You'd mentioned this, about how many innocent soldering stations you have killed over your time as a radio amateur. He's giving me the evil eye. Pete and I were talking about this on email, and he theorized that the thing broke right after I said bad things about it, or he said bad things about it. But I'm talking about my Xtronics 4000. that I bought as a result of a recommendation from George at the New Jersey QRP Club or the American QRP Club. They had this, Chat with the Designers podcast that I liked so much, and they mentioned it. So I bought one. I didn't realize it was a long time ago I bought this thing. So it's worked most of the time. But one of the things I liked about it was it had this kind of hot air blower that would blow. It wasn't just soldering, it would also hot air. The hot air was useful, but it just died and it stopped blowing hot air and it stopped heating up. And I started looking at it and I started thinking, man, I don't want to fix this thing. I'm just going to get a new one. I got a new one already. And so I started thinking about just throwing it out. Then I looked at it and I said, wait a second, it's got a great box. The box is perfect. It's perfect size box for a transceiver.
You just
and
say
it's got
QF1.
Yes, it's got ample socketry. It's got an AC line cord. It's got a transformer to go from 120 down to 10 or 12 volts.
Power supply.
It's got a couple little LCD displays on the front cover that would used to be for temperature but could be turned into frequency. So I have put that in my box of boxes for possible future rigs. So the Xtronics 4000 lives on and might perform service.
Yeah, but why did it die? Who was it? Chuck. What's his name? The you say it all the time. His blog's disappeared. What's his name?
Oh,
Chuck
yeah,
Adams?
Chuck Adams.
Didn't he say he had a soldering iron tip that he's had for 25 years?
Yeah. Yeah.
So if he can have a soldering iron tip for 25 years, why did your soldering iron die?
I know. But anyway, I've been having good ones with the new ones I have now. I have the Hakos, Hakos or Hakos. They seem to be doing pretty good. This one, the new one I have, it kind of goes to sleep when you put it in the stand. It drops the temperature down to 400 Fahrenheit, right? When you pick it up, it takes a second to come up to 700 Fahrenheit, right? So I think this actually is a lot easier on the tip. It's not sitting there cooking at 700 degrees Fahrenheit all the time.
You just got to hope that timing circuit doesn't die.
I know. Fragile stuff. Hey, Pete, time for the SolderSmoke mailbag. We're getting a lot of good mail.
Wait a minute. The Shameless Commerce Division.
Oh, the Shameless Commerce Division. Yes, that's right. Thank you for reminding me. Yeah, guys, really appreciate the folks who've been using the Amazon link up there on the SolderSmoke blog page. It's there. Just begin your search for whatever you want to search for. Just begin your search there, and we will ka-ching get a little bit of money from Bezos. We're not mad at Bezos because it turns out Bezos is a space geek.
Did you see what he did in that foreign country?
What did he do?
Well, he's got this super yacht. He and his girlfriend got this super yacht, and it won't fit under this bridge. So somehow he dangled something to this country. They're raising the bridge so he can get his yacht through. He probably said, yeah, I'll put a warehouse here. We'll hire a bunch of people. So the deal is
raise the bridge
so he can put his super yacht through.
It doesn't mean he's a bad person. He sends us money and he's a space geek. So, all right, good. Anyway, that's the Shameless Commerce Division. Thanks for reminding me there, Pete. Hey, listen, we got some great email from Mike Rainey, Alpha 1 Tango Juliet. What, the hero of the Hobbit hole. He's been down in the workshop again, producing some great minimalist stuff. He built a receiver for 486 kilohertz and used it to listen to a memorial broadcast of Fessenden's Christmas Eve, the first phones, allegedly, rumor has it, mythological, maybe not quite true. But Mike tuned in and was able to receive signals from the Fessenden Memorial transmission.
Who was transmitting in 486? Did they get special permission?
They got special permission. Yeah, they got special permission to do it. Yeah. And so, I mean, pretty close to 455 KC
yeah.
territory, but good stuff. And Michael has produced some other stuff recently too. I really hope he's getting back in the game because, man, he was an inspirational force in homebrew, QRP, minimalist radio. So we're glad to see you're back, Michael. We hope you continue to melt solder there in the Hobbit hole. Thomas, K4SWL, he runs a QRP blog, and he also runs the Shortwave Listening Post blog, two really excellent blogs. He came up with a post about amateur radio astronomy using a Raspberry Pi and some simple kind of Home Depot produced antennas with which you could map the arms of our galaxy, which I thought was really cool. Thanks for sending that along, Thomas. I got an invitation to speak to the Lance Cruise Amateur Radio Club out in Michigan from WC8C, Dennis. He invited me to speak to the club. And man, I had a great time with this. We didn't overdo it. I didn't want to sort of lecture them on why they should all be home brewers. And Dennis didn't want me to do that. He said, just share some anecdotes about your own adventures in homebrew radio. So I talked a little bit about Gene Shepard and my own kind of tales of woe, things that have gone wrong. And I think it really it resonated with these guys, no pun intended, because some of them said, yeah, I feel bad because I tried to build something, I couldn't get it to work. And I said, welcome to the club.
Yeah.
I said, Pete and I do that all the time. I pointed out that you have the shelf of shame that you put things on.
Shelf.
And I also told them, I said, they shouldn't feel bad because often the magazines that they're basing their projects on have it wrong.
Crap. Yeah.
Mistakes in QST, just legion over the years. I mean, 73 magazine, they didn't make a claim to not have mistakes. They just said, this is what some guy sent us.
Yeah. It may or may not work.
May or may not work. Your mileage may vary, but it was fun. It was good to talk to them. Hey, listen, Todd, K7TFC, out there in Portland, really been making great contributions to the blog. He got his booster shot. Now, we all got our booster shot. If we're smart, get your booster shot. I got mine. You got yours. Todd got his, but Todd got his at a cool place. He got the coolest place to get boosted. You know where he got his booster shot? At Tektronix headquarters in Beaverton, Oregon.
Is he a former Tektronix employee?
I think he used to work at Tektronix, or he worked at one of the associated companies. But I said, what a cool place to get boosted. Yeah. Holy cow. You know, it reminds me of all the jokes, all the conspiracy theories. And some guy was saying that he got boosted. And he said he didn't know if it had the desired effect, but his Wi-Fi reception was just excellent.
A lot of industries are really smart about that. My son works for a company in the Bay Area, and they send him email that says, show up this day, this time, this location, boom, get your booster shot, and it will check your employee record. Yeah.
Good,
and he
stuff.
said 12 minutes total elapsed time. 12 minutes.
Hey, listen, I became a believer. I got to say, we got to put in a plug for the vaccines and the booster. My wife and I spent a solid month or 6 weeks in the Dominican Republic, and we were dealing with, her father passed away. So we spent a good portion of it in hospitals, funeral homes, and we were fine. We didn't, and this was a place with a very high transmission rate, but I think we were really protected by the vaccines and the boosters because we both passed our test on the way out. And I thought for sure, man, if anybody's going to get it, we're going to get it just from where we've been. But we didn't. So good stuff. Anyway, go out and get boosted.
I was just going to comment. You haven't lived life until you've had a nasal swab test.
Oh no, I've had many. I know exactly what you're talking about.
Long swab. When it goes down your nose, it comes out somewhere else.
I know. It's not fun. Anyway, Todd had the coolest place to get boosted. This gets us to what happened with Chuck Adams, K7QO. You had mentioned him before. Well, he's disappeared from the internet, which is fine. All of us want to take a break every once in a while. It happens. But the weird thing here is almost all of his content has disappeared. All of the YouTube videos, his design notebook, he's disappeared from QRZ.com. This is really, strange. It's one thing to say, I'm going to take a break and go away, but a lot of us used that stuff. I really miss the notebook. I foolishly didn't download it. If anybody did download it, please send it to me because
or let us know if anybody has any information.
Or has any information. Why did this happen? It's strange because very often, like I said, you see people who just say, I want to take a break, I want to go away, but then it's almost as if there was a deliberate scrubbing of YouTube, QRZ.com. The websites disappeared. No email to contact. It's worrisome anyway, and it's a loss for those of us who depended on this really great contact. Anyway, if anybody has heard about this, please let us know. I went back through my old logbooks, Pete, and I looked at all the contacts that I made as a novice. And I said, how many of these guys are still around? It's been a while. It's been since 1973. So I just put up on a blog post all the call signs that I worked as a novice. So it was like 150 of them, something like that. And I started getting emails back, and 3 or 4 of these guys are still around. And one of
Wow.
them, WN2RTH, was one of my main contacts as a teenager. He lived like a couple towns over. And he sent me a real nice email. He's now W1MJA and is still active, and it was really great to hear from him. So, he's still active in ham radio, and I had a lot of fun. Glad to hear from him. Another blast from the past, November 7 Delta Alpha reports that he worked W7ZOI in the
Wow.
sweepstakes. That's really good. You get on the sweepstakes. I know that Wes always likes the sweepstakes. He got on there. N7DA managed to work him in the sweepstakes. I spotted on the internet, somebody found a QSL card from W7ZOI. The guy who found it had homebrewed an SSB rig, and Wes was on the air with a homebrew SSB rig. So it was a two-way homebrew to homebrew SSB contact with W7ZOI. I have a copy of the call sign. I'll put it up on the blog here, not in pretty soon. You and I, Pete, had real nice interaction with Kirk, NT0Z, formerly of ARRL headquarters. And he had some really interesting things to say. We don't want to get him into any trouble here, but he was quite candid with when he talked to Eric Guth, 4Z1UG. And he talked about how, the ARRL had participated in a dumbing down of ham radio. And there's no doubt about that. I mean, you take a look at the content of QST, the difficulty of the ham radio exams.
And it's coming from an Illuminati.
From a member. Yes, I know. Well, he's a former member of the ARRL staff. So anyway, he had a lot of nice things to say about ARRL too, to be fair. We had a lot of interaction with Farhan, our friend over there in Hyderabad, VU2 ESE. And last we heard, he was heading up to the Pench forest in India trying to spot a tiger. Good luck. You and I both spoke to his club, the Lamakan Amateur Radio Club, at their annual convention. That was a lot of fun. I had a lot of fun with that.
And they did that right. That you had to have tests and you had to be cleared and everything else. I mean, that was an example of how they got a group together and did the thing right.
And Pete, they simulcasted us on the QO100 geostationary satellite. That is, by the way, not above this part of the world. It's above the eastern part of the world. But Farhan sent me a picture of me being beamed down from geostationary orbit.
Oh, there you go.
I put that up on the blog. Very cool. Thanks to Farhan and the Lamakan Club. Dean KK7DAS, we talked a lot about his adventures. One of the things he built a 16-watt amplifier. So he's got a 16-watter on the air, and I put a video of that up on the air. Scott, WA9WFA, he's the guy I've been working with on for the Mighty Midget receiver. He and I made a discovery. We were trying to figure out why his receiver just seemed deaf when mine didn't seem deaf. And he was a really careful constructor. He'd built an HBR 13. He knows which end of the soldering iron to grab. But no matter what he did, his made for the Mighty Midget seemed quite deaf. And then we talked to Grayson about it. We kind of Googled a little bit. It turns out that the problem may have been the 6U8 tubes. They don't age well. They're long in the tooth. So you could end up with 6U8 tubes that you plug in there and you think they're fine, but the gain is way down. So one of the recommendations was, first of all, don't be too harsh on the 6U8s, but a good replacement for the 6U8 that is a little bit more recent and a little less prone to 6EA8. So I've ordered some 6EA8s. I'm going to pop them in there when they come and see if that helps. I found that just substituting tubes in mine with some of the various 6U8s that I had would result in big variations in receiver sensitivity, which was a sign. And I think then Scott tried the same thing and had similar results. So it's not looking good for the 6U8 tubes. They were very, very common. They were used in a lot of TV sets.
Collins. All the Collins radio have them in.
I got one in my Drake 2B.
Yeah.
And I checked. It's still a 6U8. It's not a 6EA8. So I'm going to try to change those out. Anyway, Bruce, KC1FSZ, sent me for Christmas a box of peppermint bark candy. And
Oh,
he builds the rigs in the peppermint bark boxes.
Yeah.
But he sent me a full box of the candy.
Oh,
And
lucky
I
you.
must say, the person who appreciated this the most was my daughter Maria, who's been eating mint chocolate since she was a little girl. So this was like, wow, this was really great. Hey, some great videos popped up from Mike WU2D. He's been doing some wonderful videos, a series of 3 on how to build analog LC VFOs. I, you know, but Mike did a really great job, and he focused a lot on temperature compensation and a great way to do temperature compensation. But I was really pleased that Mike started out with the chapter that Frank Harris wrote about how to build a VFO from his wonderful book, Crystal Sets to Sideband by Frank Harris. I think it's K0IYE. I have a link to this up on the blog. The book is free. It's just really excellent. And just for reading the chapters on the VFO, I pledged I'm going to build all future VFOs following the guidance of Frank and Mike, and I hope to have even better results in the future.
Let me interrupt you a second. One of Dean's builders in the DIY group, he 3D printed the parts to build a PTO.
Yeah.
So his rig has a PTO in it, and he did all the design work for the 3D parts, including the knob. And I mean, it's amazing. And that
I
thing
saw
is,
it. It was really cool.
Yeah. I mean, look what you can do with a 3D printer.
And they started, I think, with a kit. There's a PTO kit available that's based on a brass screw that as you turn the tuning dial, the brass screw moves into the inductor and changes the inductor value. So that is a really cool idea. And I told Dean that I wish them luck. I think the kit was sold for use up to 20 meters. 17 is a bit higher, so you should be able to do it, but it's hard to make a stable oscillator at those frequencies. So I hope they have a lot of luck with that. Let's see who else. So Bob Scott, KD4 EBM, lots of great ideas. Bob always sends me wonderful ideas. It sends me boxes of parts and VHF, UHF radios.
You got the simple transistor transceiver from him, didn't you? Isn't that the guy you got it from?
The simple.
Yeah,
which one is that?
With the NE602 that you taken with you down to the DR.
Yes, he sent me the SST, the Wayne Burdick's SST.
Yeah.
I mean, it's great stuff Bob sends. And so we always appreciate it. I love it when I get me email or a box from Bob Scott, KD4 EBM. Thanks a lot, Bob. Hope to see you at the Winterfest. The Vienna Wireless Winterfest is going to be held this year, and I will be there. I hope to see Bob there. And finally, Roger, Papa Alpha 1 Zulu. Now, I'm not sure where he is right now. They've been moving around quite a bit, but he always sends me boxes of parts with really great stuff in there. And
you got the FM radio from him, right?
Yeah, that's right. I got the FM radio and
with the pillow.
With the pillow for acoustics. Indeed, I have it here. So we're always glad to hear about that. Hey, Pete, we've been going on here about an hour and 13 minutes. Have any
a little
final...
longer. Had a little hardware problem at the front end.
I think we're okay. I think we're doing good.
And we forgot to say, crank it up, Roger, and crank it up, Ralph. We forgot to say that. No, we didn't say it. In the first one we were recording.
Oh, we did it. So anyway, we'll crank it in,
so
Roger.
We don't want to forget those guys.
Don't want to forget it. No, those guys definitely crank it in. All right, we didn't forget. All right, Pete Giuliano, thanks very much for joining us early this morning. And we hope it won't be so much time between now and the next SolderSmoke podcast.
And I had a little fun yesterday. I talked to my son who lives in Midtown Manhattan, where it was 19 degrees, and we had 72 degrees outside. And I kept telling him that there I was in a short sleeve shirt, and it was 72 degrees out. He said,
"Oh man, it's colder yesterday." But I don't feel bad. I spent December and January in the Dominican Republic, where it was white shirt sleeve.
Yes.
All right, 7-3 from Northern Virginia.
7-3 from the left coast.
Thanks, Pete.